Question 17 says that radioactive decay of material is determined using the formula N equals N naught times E to the power of negative KT. Then it asks us to find the constant K for plutonium-239, given that its half-life is 24,390 years. So I'm going to rewrite this formula we've been given, which is N equals N naught times E to the power of negative KT. And to explain some of the variables we have in this formula, our T is our time, and in this case it's in years, and our N naught is the initial amount of whatever material we're interested in. Our N is the final amount of this material, and so this, and E of course is just a constant. So this formula is going to work for any amount of time t. So it basically says that for any amount of time and a starting material, what are you left with after it's decaying? So in our case, though, we're looking at a special circumstance where we're told the half-life of this material. So in the case where T, so if T equals the half-life, we know that half-life means the time for a material to decay by half of its original amount. So if T is equal to the half-life, then our final amount N is equal to 1/2 of N naught, our initial amount of material. So we can use this to simplify our equation here and figure out K, which is what we're interested in. So I'm going to plug in what we've been told. In this special circumstance, our N is equal to 1/2 N naught. So I'm going to plug that in for N up here. And that equals N naught times E. And we've been told that the time in this case is 24,390 years. I'm going to put the negative in front of that and say that's times K, and K is what we're trying to find. So the next thing I can do is divide by N naught on both sides of my equation. This is going to nicely cancel out N naught, leave us with 1/2 on this side of the equation. We have E to the power of negative 24,390 times K. And so to get rid of this E here, what we want to do is take the ln of both sides of our equation, because we know that ln has a base of E. So doing that, we get ln of 1/2 equals ln of E to the power of negative 24,390 times K. And so on this side, we're left with ln of 1/2, but on the right side, what we essentially have here is E to the power of something equals E to the power of this whole expression here. So we know that this will just evaluate out to our exponent. So on the right side, we're left with negative 24,390 times K. And so the next thing to do is to just divide both sides of our equation by 24,390, negative 24,390 on this side as well. And when we evaluate that out, plug it into our calculators, what we get, sorry, this should be squiggly lines. It's quite a long decimal. So we get K is equal to about, I'm actually going to write this on this side because I don't even have room on that side for this long decimal. K is about 0.00002842. So this is essentially our constant K for plutonium-239.